Hey, Mohammed. So, quantum computing, right? Like, for years, it's felt like this futuristic dream, almost science fiction. But I'm hearing more and more about it popping up in, of all places, finance. Is that actually happening, or is it still, hype?
Emma, it's funny you ask, because you're absolutely hitting on the pulse of it. For a long time, it was very much in that promising, but not quite there. Like almost a running joke. But honestly, in the last little while, something's genuinely shifting. We're seeing banks, hedge funds, even these ambitious fintechs. They're not just talking about it anymore. They're actually exploring quantum algorithms for things like, well, portfolio optimization, pricing derivatives, even fraud detection and risk modeling. It's really quite exciting, actually.
Oh, wow. So it's not just theoretical then, like real-world applications? That's pretty wild, eh?
Exactly. It's no longer just science fiction. It's running quietly in pilots right now, behind NDAs, in white papers. But I must say, we're not at the tipping point just yet. The hardware, it's still what they call the noisy intermediate stage. So, tentative ROI, difficult to quantify immediately.
Okay, noisy intermediate stage sounds intriguing. But tell me, where is quantum really shining? Like, where are they seeing the clearest entrance? You mentioned portfolio optimization, for instance. How does it actually help with that?
Right, right. So modern finance, it absolutely thrives on optimization problems. And some of them are they're so complex, they make classical systems, even Excel, just cry. Quantum algorithms, they're proving really, really useful in tackling these, especially when you've got things like asset correlations, time constraints, and these unexpected black swan events all colliding. Classical systems, they scale poorly with high dimensions, but quantum methods, like something called QAOA, they offer new paths. It's less about quantum solving everything, Emma, and more about it tweaking something hard in a way that matters at scale.
That makes sense. So it's not a magic bullet, but it's a powerful tool for specific, really tough problems. And what about risk modeling then? That sounds like another big one.
Absolutely. Risk modeling and derivatives pricing, they're inherently about uncertainty. Quantum Monte Carlo, for example, shows promising faster convergence for pricing very exotic instruments.
And then there's fraud detection, Emma, transaction monitoring today is like a monumental needle in a haystack problem, and the haystacks just keep growing. Quantum machine learning, it has this incredible potential to identify really subtle anomalies that often escape classical detection, especially in those cross-border high-velocity systems. It's also interesting because quantum, while it can break some forms of encryption, it simultaneously enables more advanced detection and prevention layers. So a powerful tool for security?
That's fascinating. So it's almost like it's evolving the security game on both sides. And I imagine this isn't just a North American thing either, is it? Like, who else is really pushing this forward globally?
Oh, totally not. The global picture is quite diverse. We see the US, Europe, the UK, Canada, like we have one qubit right here, right? Japan, Singapore, even China, they're all heavily investing. JP Morgan, Goldman, Bank of England, multiverse computing. It's a global chessboard being arranged, really.
So it's a global race then, but you mentioned blockers. What are the big hurdles still? Because it sounds incredibly promising, but there's always a but, eh?
Absolutely, Emma. There are definitely friction points. The hardware, first point, is still quite noisy. NISQ, or Noisy Intermediate Scale Quantum Machines, meaning error rates are just too high for mission-critical deployments right now. Then, ROI is foggy for many CFOs. Quantum pilots rarely deliver those near-term numbers that justify continued heavy investment. And perhaps the biggest one, the thing is, well, there's a massive talent gap. finance professionals, they just don't speak quantum, and quantum researchers don't speak finance. Translators, they're few, and they're in very high demand.
Yeah, that's a tough one to bridge. So, what's the outlook then for 2025 and beyond? Are we going to see this become mainstream anytime soon?
Not mainstream immediately. We're looking at quiet pilots growing in complexity, hybrid systems dominating until 2027. Maybe by 2032, if error-corrected machines scale, we see meaningful advantage. Finance might actually be one of the first industries to hit quantum mainstream because, milliseconds equal millions.